All right, and here we go again. More writing equations. All right, now today we're going to look at something very specific to do with linear equations, right? And that's going to be the relationship between parallel and perpendicular lines and how we can write equations of those types of lines. All right, so once again, this gets into that various context, all right, idea of standard 7.1. Now, here's what you're going to do, because a lot of this video is really you doing the work and then coming back, all right, and going through the video and seeing what patterns you saw. So there are, all right, for the opener, you have page 1 here, all right? Then you have the next page, which is page 25 in your booklet, and then, all right, 26 and 27. So you're going to go all the way up to part N, all right? And so what you're doing, right, is just kind of side to side here, right? So identify your slopes, graph the lines. What do you notice, right? Identify your slopes, all right? Graph the lines. What do you notice? And you're going to do this, all right, on 4 different pages. And the idea is hopefully once you've done that exploration, all right, you'll see some patterns, all right? So this is probably going to take you, 8 to 10 minutes, maybe 15 minutes, all right, but please go through it properly, right? So really do the work. One, is going to be a great review of graphing lines because we just did that, all right, a couple of units ago. All right, or in the last unit actually. So it'll be a good review for you, but then also making some connections to what we're going to do now. So go ahead and pause the video and then flip it back on and we'll go through and see how things went for you. All right, so let me pull up my work, all right, and let's kind of go through this. So when you look at the first page here, all right, hopefully you saw that both lines had a slope of 3, and then you graph both lines, all right, and they had a slope of 3, all right, same slopes, and the lines didn't intersect. If I come down to the next one here, both of these lines have a slope of 1/4. Once again, we have equal slopes. Once we graph them, they didn't intersect either. All right. And so then if we keep going, right? So now instead of having equations, we had points. And so this is pulling in what we talked about last time, right? Just make a quick XY table. All right. And once again, all right, if I reduce both of those slopes, you get a slope of 4 to 1. So once again, they're equal. I graph the lines, they don't intersect. All right, same thing again here, right? 2 points, create an XY table. And once again, notice this is why we want to reduce, right? Because once I reduce, I can see that I have a half and a half. Those slopes are equal, and they don't intersect. So hopefully what you saw on these first 4 parts of the opener, right, is if the slopes are equal, then the lines don't intersect as long as it's not the same line. All right, so hopefully you picked up on that pattern. All right, now let's look at the next set of 4 graphs. All right, so now when I look here, my slope is 1/3 and my slope here is -3/1. So what we wanted you to see is 2 things. One, hopefully you saw that one is positive, one is negative, and then they're flipped. All right, and the word we say for that mathematically is reciprocal. All right, now that may be an unfamiliar term to you, and you might have used flipped or reversed or something to that nature, right? But reciprocal is the official mathematical term for when this happens. Now, what did you notice here? These lines definitely intersect, right? The first 4 we looked at did not intersect. These definitely intersect. And if you look at it, they look like they intersect in a very specific way. All right, it almost looks like a very formal T, just a little bit slanted, right? And turned. All right, so let's come back to this. So we definitely know that they intersect, right? Now, when I look at part I here, once again, I get 4 to 1, -1 to 4. So we still see this opposite and flipped, right, or reciprocal. All right. And then once again, we can see that they definitely intersect. And once again, right, it looks like they're intersecting in a very specific way. All right, so now let's go and look at the last 2 graphs. Once again, these involve the points, right? Find your slope, all right, from making your XY table, 2 to 1, -1 to 2. Once again, they definitely intersect, all right? And you see that they're opposite and flipped. And once again, I'm just going to try to move you to a little bit more of the formal language. They're reciprocals of each other. And finally, you see the same thing again here, right? And once again, this is why we want to reduce. 15 to 3 doesn't look like the reciprocal of 1 to 5, right? But if I reduce it, then it does. So we get this opposite and reciprocal relationship again. And once again, we get this intersection here. So here's what we hopefully wanted you to see, right? So one, hopefully you saw that if, right, slopes are opposite and reciprocal, lines intersect, right? And here's what we want you to know that they intersect in a specific way. And the way they intersect, all right, is that they form a right angle. They are perpendicular to each other. The lines intersect, all right, to form right angles. And this means they are perpendicular. All right, and this is really typically how things are constructed, so like the floor to the floor and the ceiling, or excuse me, the floor and the wall, right? We want those 90-degree angles, right? So like a straight L or a T. And so anytime we have this relationship, we get this idea of perpendicular lines. Now that may or may not have been familiar to you, and that's totally fine. Okay, so now let me open up flip my notes. If we go to the next page, let's summarize those results, right? Okay, and so now you can see that, okay, so we have these parallel lines. Parallel lines are lines that will never intersect. All right, so we need a little typo there. Parallel lines are lines that will never intersect, okay? The equations of parallel lines will have the same slope, all right, but we'll have different y-intercepts. And that just means that we need a different place to start, right? So they're not the same line. Because if they're the same line, then they're not really parallel because they intersect all the time. Okay? Now, perpendicular lines intersect to form, all right, 4 right angles. And you'll typically see this like little box looking guy there. All right, and that means all 4 angles are right angles. So the equation of perpendicular lines will have opposite and reciprocal slopes. All right, and then we know they're going to intersect, so they don't necessarily have to have different y-intercepts because we know we will always get a point of intersection with perpendicular lines. All right, so that's how we know if lines are parallel or perpendicular. All right, now how are we going to use this information? Well, we're going to write equations of lines that would be parallel to a given line or perpendicular to a given line. Okay, so let's drop down, all right, to number 1 here. So what we want to do is learn, right, to recognize pieces, which I think for most of you, you're getting very good at this. So what would the slope of a line parallel to each given line be? So when I look at this equation, I have to know what the slope is. Well, the slope of this line is 3 to 1. So if I want my line to be parallel, I need the exact same slope, all right? So that means I would want my slope for my parallel line to also be 3 to 1. Well, when I look at part B here, right, here is my slope. So 2 to 1. So if I want my line to be parallel, I need to use the exact same slope. So I'd want my new slope to be 2 to 1 as well. All right, and then same thing for part C. Identify the slope of that line. It is 1 to 2. So I'd want my new slope to be, all right, the exact same to make my lines parallel. All right, so the first thing is that we have to recognize the slope in our given line. And then we're going to pull that slope, we're going to extract that piece of information and use it to write a new line. So now let's look at number 2 here. So now what we want to do is write the equation of a line passing through the given point and parallel to the given line. And we're just going to write our answer in point slope form. All right, so once again, right, x minus x1 plus y1, this is our blueprint for our line. All right, so notice, all right, here's the given line, and we want our line to be parallel, so we want the exact same slope. So when I look, here is the slope of this line. And so I'm just going to take that and use that exact same slope in my new equation. Now then I want my equation, my new line, my parallel line to go through this point that's given to me, which is 1, 3. So I just throw that in to my equation like that, and we're done. And that is it. So I just have to be able to take and find that slope in this line, and I want to use the exact same slope to make it parallel. All right, so let's look at B here. So once again, right, here's my given line. I want my new line to be parallel to this line. So I want to take the exact same slope from that line. And the 1 over 3 is that slope. So I'm going to take that and I'm going to use that in my new line. And then my new line has to go through the point 5, 3. And so I'm going to just toss that in like that. And there's the equation of my parallel line. Okay, so now let's just do a little bit of practice on the perpendicular line. All right, so let's look at problem 3 here. Okay, so we're just going to start once again by identifying slope and then writing what our new slope would be. So we want our slope to be perpendicular this time. All right, so once again, we have to identify my slope. So the slope in this given line here is 3 over 4. Now remember, with perpendicular, we need two things, right? To be perpendicular, we need the new slope to be opposite and reciprocal. All right, opposite and reciprocal. So since this is positive, I know the opposite has to be negative. And the reciprocal means flip that ratio. So instead of being 3 over 4, it would now be 4 over 3. And that would be the slope of my line that would be perpendicular. All right, let's go to our next slope here. All right, so the slope here is 2 over 1, excuse me, negative 2, and then over 1. Remember, we want to put every whole number over 1 to see that ratio, because now that's important, because now when I do the reciprocal, right, I need to know what that denominator is. So once again, we need two things. We need it to be opposite. So since this is negative, our new slope would be positive, and then we take that reciprocal, and it would be 1 over 2. All right, and finally on part C, when we identify the slope right here, right, we can see that it's negative 5/6. So to make it opposite, I want my new slope to be positive, and then I do the reciprocal, that would be 6 over 5. All right, so now we're going to basically do what we just did a second ago with parallel lines, but now we're going to do this with perpendicular lines. So here is my given line, and I want my new line to be perpendicular to this line and go through the point 1, 3. So identify slope first. My slope of this line, right, is negative 3, and then I'm going to put that over 1. So to make my line perpendicular, I first need to make that slope opposite and reciprocal. So since it's negative, I'm going to make it positive, and then the reciprocal would be 1 over 3. And then it tells me it has to go through the point 1, 3, so then that means it's going to be x minus 1 plus 3. Okay, now moving to B. Our last example here, my slope of this line, right, is 3 over 2. To make my line perpendicular, I need to do two things to that slope. I need to make it opposite. So since this is positive, my new slope needs to be negative. All right, and then I have to do the reciprocal, so my new ratio would be 2 over 3. It has to go through the point 4, 2. So if I put that into my point slope form, x minus 4, and then plus 2 is that. All right, so that is how we write the equation of parallel and perpendicular lines. All right, have those notes ready, and we will do a little bit more practice next time. See ya.